Alright, welcome to lesson 2 of module 2. In this lesson, we're going to take a bit of a step back in time and we're going to look at how the view on maintenance developed over time. Understanding when and why and how maintenance changed throughout history will help us understand the topics we're discussing later in the course. So let's jump in. There are two key points I want you to take away from this lesson. First of all, you need to understand how our collective knowledge of effective and efficient maintenance made a step change in the 1960s and the 1970s with the development of reliability-centered maintenance. And secondly, you need to understand that the different maintenance generations referred to in literature build on each other. They don't replace each other. And in this lesson, I will talk about first, second, third, and eventually fourth generation of maintenance. And that is essentially the move from breakdown maintenance to preventive maintenance to reliability-centered maintenance and now towards predictive maintenance based on the Internet of Things or the industrial Internet of Things. But what is crucial to remember, and we're going to come back to this on this point several times in the course, is that an effective maintenance program uses strategies from all four of these maintenance generations. These maintenance generations should be seen as building on each other, not replacing each other. So for most of human history, we've had a very simple approach to maintenance. We fix things as they broke. And that served us pretty well from our very early days huddled around campfires until about probably World War II. Now in the early days of industrialization, equipment was not very complex or highly mechanized. And downtime was not really a major issue, and preventing failures wasn't a concern, it wasn't a priority. And at the same time, most equipment in use was simple, and more importantly, it was over-designed. So equipment was robust, reliable, and relatively easy to repair. Most plants operated without any real preventive maintenance in place. There might have been some cleaning, some minor servicing or lubrication, but that was about it. So this simple fix-it-when-it-breaks approach to maintenance is often referred to as first-generation maintenance. Now, with the arrival of World War II, things really changed. Wartime increased the demand for many diverse products. And at the same time, the supply of industrial labor dropped significantly. With most men drafted into the armies, a lot more women came into the workforce, and in occupations they had never worked in until then. But even then, labor remained a big constraint in wartime economies, and so productivity became a really important focus. And as a result, mechanization increased. By the 1950s, more and more complex machines were in use across all industries. Industry as a whole had come to depend on machines, and machines that became ever more complex. And as this dependence grew, it became more important to reduce equipment downtime. Fix it when it's broken no longer suited industry, and a focus on preventing equipment failure started to emerge. And slowly the idea took hold that failures could be prevented with the right maintenance at the right time. In other words, the industry moved from breakdown maintenance to time-based preventive maintenance. Fixed interval overhauls or fixed time replacements to prevent failures became the norm. And this approach to preventive maintenance is typically referred to as second-generation maintenance. Now, after World War II, air travel became widely accessible and passenger numbers grew really fast, but not without problems. By 1958, the United States Federal Aviation Administration, the FAA, had become quite concerned about reliability in the aviation industry and about passenger safety. And at the time, the dominant thinking still was that components had a specific life. The thinking was that components would fail after reaching a certain age. So replacing components before they reach that age would therefore prevent failure. And that was how you ensured reliability and, in the case of airlines, passenger safety. In the 1950s and the 1960s, the typical aircraft engine overhaul was every 8,000 hours. So when the industry was faced with an increasing number of failures, the conclusion was easy. Obviously, component age must be less than 8,000 hours than that was being assumed. So maintenance should clearly be done sooner, more frequent. And so the time between overhauls was reduced. Pretty easy, right? But Increasing the amount of preventive maintenance had three very unexpected outcomes. Outcomes that eventually turned the maintenance world upside down. First of all, as the airline started to do more maintenance, some failures became less frequent. And that was exactly what everybody expected to happen, so all good. The second outcome was that a larger number of failures occurred just as often as before. That was not expected and pretty confusing. The third outcome was that most failures occurred more frequently. In other words, doing more maintenance led to more failures. And that was counterintuitive, and to be honest, it was a big shock to the system. These results frustrated both the FAA and the airlines. The FAA worried that reliability had not improved and passenger safety was still a risk. And the airlines worried that the ever-increasing maintenance burden was not yielding the result. So during the 1960s, the airlines and the FAA established a joint task force called the Maintenance Steering Group to find out what was going on. And after analyzing 12 years of data, the task force concluded that overhauls had little to no effect on overall reliability or safety. For many years, engineers had thought that all equipment had some form of wear-out pattern. In other words, as equipment aged, the likelihood of failure increased. But the study found that this universally accepted concept just was not true. Instead, the task force found 6 patterns describing the relationship between age and failure. And for the majority of failures, the occurrence was random, rather than based on age. Now, the task force findings were used to develop a series of guidelines for airlines and airplane manufacturers on the development of reliable maintenance schedules for airplanes. The first guideline, titled Maintenance Evaluation and Program Development, came out in 1968. Now, this guide is often referred to as MSG-1, and it was specifically written for the Boeing 747-100. The maintenance schedule for the 747-100 was the first to apply what we now call reliability-centered maintenance concept using MSG-1. And it achieved a 25 to 35% reduction in maintenance costs compared to prior practices. As a result, you can imagine, the airlines lobbied really hard to remove all the 747-100 terminology from MSG-1. And they wanted the maintenance schedules for all new commercial airplanes designed using the same process. And the result was MSG-2, which released in 1970, titled Airline Manufacturer Maintenance Program Planning. Now, the move to third-generation maintenance or reliability-centered maintenance as outlined in MSG-1 and MSG-2 was pretty dramatic. The DC-8 maintenance schedule used traditional second-generation maintenance concept. It called for more than 4 million labor hours before reaching 20,000 operating hours. Look at that again. It called for more than 4 million labor hours before reaching 20,000 operating hours. Compare that to the maintenance schedule for the Boeing 747-100, developed using MSG-1, the precursor to modern-day RCM. It required just 66,000 labor hours before reaching the same 20,000 hours of operating time. Now, another interesting comparison is to compare the number of items requiring fixed-time overhauls. In the case of the DC-8, a massive 339 components were subjected to time-based overhauls. The maintenance for the DC-10, which was developed using MSG-2, required the overhaul of just 7 items versus the 339 on the DC-8. And both the DC-10 and the 747-100 were larger and more complex than the DC-8. So these were pretty impressive results. And the US Department of Defense thought so too. So in 1974, the Department of Defense asked United Airlines to write a report on the processes used to write reliable maintenance programs for civilian aircraft. And so in 1978, Stan Noll and Howard Heap published a report. It was titled Reliability-Centered Maintenance. And RCM became the beginning of the third generation of maintenance, which made the shift from being time-based to reliability or risk-based. Since then, a lot more work has done to progress the cause of reliability-centered maintenance. The airline industry has moved to MSG3, and I think even beyond that. John Mowbray published his book RCM2 in the 1990s, introducing reliability-centered maintenance concepts to industry at large. And more recently, RCM2 has moved to RCM3 with an ever stronger focus on risk management and aligning towards asset management and the ISO 55000 series of standards. But change did not stop. And from the 1990s onwards, there's been a tremendous shift in technology, with ever cheaper and more powerful computers. Now, if you look at the graph here, you can see the green line, and that is a reflection of computer speed. And you got to keep in mind that this is a log scale. So since the early 1990s, microprocessor speed has increased for more than 10,000 times. And at the same time, the cost of almost any type of sensor has come down dramatically too. The internet has become mainstream. Cloud computing is the norm. In recent years, machine learning and artificial intelligence have both moved ahead in leaps and bounds. And as a result, we're now seeing a rapid move towards much more condition-based and predictive, prescriptive maintenance. And although maybe that's not yet formalized in our industry literature yet, more and more people clearly see this as the next generation of maintenance, the fourth generation of maintenance. Now, this is an exciting new generation of maintenance, and we don't know yet really where it's going to take us, but most plants out there in the real world would be wasting their time chasing after fourth generation maintenance practices, as unfortunately most of these plants still don't have the basics in place. Look, during my career, I've worked in some very advanced high reliability plants where we consistently achieve reliability of complex turbo machinery at 99.9%, day in, day out, week in, week out, month in, month out. And we used a lot of advanced technology, we applied condition-based maintenance, and we were doing what some might call predictive maintenance. But I'm convinced that the secret to our success was not the advanced technology. It was that a lot of basics were in place and that there was a very strong focus on continuous improvement. So the one health warning I want to give here is this: make sure you don't fall prey to the latest trends and focus first on implementing what we've learned from the previous maintenance generation. So having talked through the 4 generations of maintenance, this slide summarizes the 4 generations graphically and builds on the diagram shown in Mowbray's book RCM2. The slide shows the 4 maintenance generations, when they occurred, and lists for each maintenance generation the key factors behind that specific generation. Now, I'm not going to discuss this slide in detail, as that would essentially repeat what we've just been through. But you can download this slide from the resource section in this lesson, and it's going to be a very useful reference, maybe something worth hanging in your workstation. And of course, it is also going to be available in the overall slide deck for this lesson. So that brings me to the end of this lesson. In this lesson, we talked about how the development of RCM in the 1960s and 1970s led to a step change in our understanding of effective and efficient maintenance. What we as an industry learned in this period is critical to your success. And in the next lesson, I will summarize this by discussing the principles of an effective preventive maintenance program. The other key point I want you to take away from this lesson is that although through history we've moved from first generation to fourth generation maintenance thinking, each generation of maintenance thinking has a role to play in your overall program. So although the industry moved from breakdown maintenance to preventive maintenance to reliability-centered maintenance and now towards predictive maintenance based on the industrial Internet of Things, you got to remember that an effective maintenance program uses strategy from all 4 of these maintenance generations. These maintenance generations should be seen as building on each other, not replacing each other. Alright, with that said, I'm looking forward to seeing you in the next lesson.